Welcome to this detailed walkthrough of the FeedBase Basic main interface. In this video, we'll explain the entire main screen step by step, including what every section does, how each control affects the formulation process, and how to use the program efficiently to create least-cost feed formulas while meeting nutritional requirements. Top section, Basic Configuration. At the top of the interface, we have the main configuration area. The first field is animal type. This is where we select the species or production type we want to formulate for. In this example, the selected animal type is broiler. This selection is very important because the program automatically loads the correct nutritional specifications, feed stages, and formulation data related to that animal type. For example, broilers, layers, breeders, ducks, and turkeys all have different nutritional requirements. So FeedBase adjusts the formulation environment based on this selection. Next, we have feed type. This is where we select the feeding stage. In the current example, the selected stage is starter. Each stage has its own nutritional targets. Starter diets usually require higher protein and amino acid levels compared to grower or finisher diets. When the feed type changes, FeedBase automatically loads the nutritional specifications assigned to that stage. Next is solver mode. This determines how the formulation process will work. When the mode is set to solver, FeedBase uses the optimization engine to calculate the best possible formula based on ingredient prices, nutritional requirements, ingredient limits, and selected constraints. Other modes may allow manual evaluation or testing of formulas without running the automatic optimization process. Below that, we have feed days. This displays the feeding period associated with the selected stage. For example, here it shows 0 to 10 days, meaning this formula is intended for birds from day 0 to day 10. This helps the nutritionist quickly identify the target age range for the formula. Left section, Feed Formulation Table. Now let's move to the left side of the screen, which contains the Feed Formulation Table. This is the ingredient formulation area where all feed ingredients are managed. Feed ingredient column. The first column is feed ingredient. This contains the names of all ingredients available in the formula. Examples include maize, soybean meal, oils, limestone, phosphates, amino acids, vitamins, minerals, and additives. Each ingredient has its own nutritional profile stored in the database, and FeedBase uses those values during formulation calculations. Price per ton column. The next column is price per ton. This is the ingredient price per ton. Ingredient price is one of the most critical parts of least cost formulation because the solver always tries to achieve the nutritional targets at the lowest possible total cost. If an ingredient is expensive, the solver will only use it when necessary. If another ingredient provides similar nutrients at a lower cost, the solver may prefer the cheaper option. Kilograms column next is the kilogram column. This displays the quantity of each ingredient used in the final formula. After running the solver, FeedBase automatically fills this column with the calculated inclusion rates. In manual mode, users can also enter ingredient quantities directly to evaluate custom formulas. Percentage column. The percent column displays the inclusion percentage of each ingredient. This makes the formula easier to read and analyze, especially when comparing ingredient contribution levels. Min column. The min column is used to define the minimum inclusion level for an ingredient. If the user wants a specific ingredient to always be included at a certain amount, the minimum value can be entered here. For example, soybean oil may have a minimum of 3, sodium bicarbonate may have a minimum of 0.75. This means the solver cannot go below those levels during optimization. Minimum constraints are commonly used for maintaining pellet quality, ensuring additive inclusion, preserving ingredient functionality, or enforcing management decisions. Max column. The max column defines the maximum allowed inclusion level. This prevents the solver from exceeding practical or nutritional limits. For example, maize may have a maximum inclusion, soybean meal may have an upper restriction. Certain additives may only be allowed at very low levels. The solver always respects these limits during optimization. So in summary, the formulation table tells FeedBase which ingredients are available, how much they cost, and what limits are allowed for each ingredient. Right section, Nutrient Requirements Table. Now let's move to the right side of the interface. This section contains the Nutrient Requirements Table. This is where FeedBase manages all nutritional constraints and nutritional analysis. Analysis Items column. The first column is Analysis Items. This contains the nutritional parameters used in formulation, such as metabolizable energy, crude protein, amino acids, minerals, vitamins, electrolytes, fiber, fat, and trace minerals. Units column. The Units column displays the measurement unit for each nutrient. For example, energy uses kilocalories, protein and amino acids use percentage. Trace minerals may use milligrams. Vitamins may use international units. The actual column displays the real nutritional values achieved by the current formula. After the solver runs, FeedBase calculates the nutrient contribution from all ingredients and shows the final achieved values here. This allows users to compare the final formula against the nutritional targets. Standard column. The standard column contains the target nutritional requirements. Examples include 2,975 kilocalories for energy, 22.50% crude protein, 1.32% lysine, 0.95% calcium, and so on. These values are automatically loaded based on the selected animal type and feed stage. However, users can also manually adjust these values directly from the interface whenever needed. For example, if protein seems too high for current market conditions, it can be reduced temporarily. If lysine or energy needs improvement, the target can be increased manually, or users may test alternative nutritional scenarios quickly without changing the database. This gives complete flexibility during formulation and allows rapid experimentation. But there is an important distinction. Manual edits made directly in the interface are temporary and apply only to the current formulation session. If the user wants a value to remain permanently assigned to that stage every time the program opens, the change should be made inside the specs table in the database. The specs table is the main nutritional source used by FeedBase for all animal types and feeding stages. So, editing values in the interface equals temporary adjustment. Editing values in the specs table equals permanent program-wide modification. Sources column next is the Sources column. This is related to nutrient source management. It allows advanced control over how certain nutrients are supplied inside the formula. This feature becomes especially useful when users want nutrients to come from specific ingredient sources or want tighter control over formulation behavior. Selected column. The final column is Selected. This is one of the most important columns in the entire program. When a nutrient is checked, FeedBase treats it as an active optimization constraint. That means the solver must satisfy that nutrient requirement during formulation. For example, energy, protein, lysine, methionine, calcium, sodium, phosphorus may all be selected as required constraints. Unchecked nutrients may still appear in the analysis results, but the solver will not force the formula to meet them. This gives the nutritionist flexibility when building practical or economical formulas. Selecting too many unnecessary constraints may make formulation more difficult or even infeasible. Cost per ton section. At the top of the nutrient table, we have cost per ton. This displays the final formula cost after solving. FeedBase calculates the total formula cost based on ingredient prices, ingredient inclusion levels, and total formulation composition. This is one of the key outputs of least cost formulation. Bottom buttons, main actions. At the bottom of the interface, we have the main control buttons. Solve button. The Solve button runs the optimization engine after setting. Ingredients, prices, limits, nutritional requirements, and selected constraints. Clicking Solve starts the least cost formulation process. FeedBase then calculates ingredient quantities, achieved nutrient levels, and final formula cost. Tables button. The Tables button opens the database management section. This allows users to manage ingredients, nutrient values, specifications, prices, feed stages, and related formulation data. This area is essentially the back-end data control center of FeedBase. Export Excel R button. This button exports the formulation report to Microsoft Excel. The exported report includes ingredient composition, nutritional analysis, and formula cost in a professional and formatted layout. Export PDF R button. This exports the report directly as a PDF file. This is useful for printing, sharing, customer reports, or archiving finalized formulas. Nutrient Sources button. This section is used for nutrient source management. It provides advanced nutritional control over ingredient contribution behavior and nutrient sourcing logic. Shadow Price button. The Shadow Price section provides advanced economic diagnostics. It helps identify which nutrients are increasing formula cost, which constraints are limiting optimization, and which nutritional targets have the strongest economic impact. This is extremely valuable for professional feed formulation and cost analysis. Activate/License button. This button manages software licensing and activation. Users can activate the software, review subscription status, check expiration dates, and manage licensing information. Close button. The Close button exits the program. Activation status area. At the bottom left corner, FeedBase displays the activation status. This includes activation state, subscription type, remaining days, and expiration date. This helps users confirm that the software is properly licensed and active. Final summary. To summarize, the main interface is divided into three major sections. 1. Top configuration area, animal type, feed stage, solver mode, and feed days. 2. Left formulation table, ingredients, prices, inclusion limits, and formula composition. 3. Right nutrient table, nutritional requirements, achieved values, and optimization constraints. The typical workflow is simple. Choose the animal type, select the feeding stage, review ingredient prices, define minimum and maximum limits, select nutritional constraints, then click Solve. FeedBase will then generate the optimized feed formula, the achieved nutritional analysis, and the final formula cost. The goal of FeedBase Basic is to simplify feed formulation, reduce manual calculation errors, save time, and produce practical least-cost feed formulas based on real nutritional and economic constraints.